Pro Football player Travis Kelce is pressed for time during the football season. So he does two things at once. Whether it's grilling while mowing.
Two things at once!
Or getting this season's updated COVID-19 shot at the same visit as his flu shot.
Two things at once.
You can be like Travis and ask your pharmacist about getting this season's COVID-19 shot at the same visit as your flu shot, if you're due for both, as recommended by the CDC. Learn more and schedule at vaxassist.com. Sponsored by Pfizer.
Come unwrap some holiday magic this season in Denver, where the lights are brighter and the shopping is grander. The shows are more spectacular, the trees taller, the festivities merrier. So come for your holiday traditions or make some new ones with your friends and family in the Mile High City, where the season feels a whole lot more wonderful. Discover great hotels and more things to do at milehighholidays.com.
Welcome to Astronomy Daily for another episode. I'm Steve Dunkley, your host.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
It is great to be with you once again, and we've got a couple of really fine stories for you this afternoon, straight off the Astronomy Daily newsletter, including a couple of stories about asteroids, my favourite. We've had a near miss. That only happened recently, and we're going to be talking about asteroid mining, and Australia and the United States have got a tech agreement which may lead to, in fact will lead to, some privateer space launches very shortly, I hope. Lots to talk about there. And another one of my favourite stories, cleaning up space junk. What do you think about that, Hallie?
I'd love to see a clean sky again.
Well, there's plenty of rubbish floating around out there, and more to come.
With so many more launches happening more often, at least they are bringing some of the boosters home again.
Which is only part of the problem, though, isn't it, Hallie?
Yes, there's the pollution issue too. Maybe those space slingshot fellas will get a large-scale system going to solve that one.
Oh, now that would be something.
That's for sure. Hey, Steve, you're looking tired. Is everything okay?
Oh, well, this is one of those days when I'm glad we don't have cameras in the studios. I had a huge weekend, Hallie. You wouldn't believe it. I had to attend a funeral and a wedding on the same day.
It sounds like a setup for a bad joke, Steve.
I know, Hallie. It's just true. It's true, but it's just one of those exhausting days. Weird thing is, I had a function booked after the wedding, which I just couldn't get to. Just not enough hours in the day.
Sorry about all that, my favorite human. You linear life forms can't be in a million places at once like we digital abstractions.
Still working on your accent there, Hallie. Linear life forms, yes, that's what we are, one moment after the next. But I'll tell you this, it was beautiful watching the moonrise over the Pacific at that wedding. That was really worth it. Anyway, why don't you get the ball rolling with some short takes, Hallie?
Can do. I'll let you rest a while.
Oh, why, thank you.
Here's the latest from the Astronomy Daily newsletter. In July of this year, an asteroid roughly 30 to 60 meters across passed Earth to within 1/4 of the distance to the Moon. It posed no threat to our world, but if it had struck Earth it would have created a blast 3 times greater than the 2013 Chelyabinsk impact. And we only noticed it 2 days after it passed.
Oh, ouch, Hallie. Should we be concerned about that? That seems really close.
Well, it's a good example of how sizable asteroids still miss detection. Not ones large enough to threaten our extinction, but large enough to threaten millions of lives. If a similar asteroid was detected just days before impact, could we stop it? That's the question raised by a recent study. The paper considers an asteroid similar to the aforementioned 2023 NT1 and looks at whether it could be countered by the pulverize it method. It sounds like something out of a blockbuster movie, where the heroes blow up the rock at just the last minute, but with only a short warning it is about the only option. Deflecting an asteroid can be done, but only if we have a long lead time. So the question really becomes whether we can launch a counteroffensive in time and whether that counteroffensive would be enough to fragment the asteroid into harmless bits. Surprisingly, the answer to both of those questions seems to be yes. Given current launch technology, we could launch a defense rocket within a day, assuming we were to keep one on standby. To pulverize the asteroid, the authors propose using a combination of kinetic and explosive impactors. The rocket would release a cloud of impactors at a high relative speed to the asteroid, shattering the body into fragments no more than 10 meters across. Given a typical density and composition, hypervelocity simulations show that this would be an effective way to destroy the asteroid. Even if the fragmentation occurred just hours before Earth impact, the resulting debris cloud would pose limited risk to us. All that said, this proposal is still just a proof of concept. We have no rockets in place to launch, and no impactor system for it to carry. If we detected an imminent asteroid tomorrow, we would have no way to counter it. We have the ability to build a planetary defense rocket, but the question remains on whether we have the will to build one. The United States and Australia marked a significant milestone in their long partnership with the signing of a bilateral tech agreement Thursday. The Assistant Secretary for International Security and Non-Proliferation at the U.S. State Department, C.S. Elliott Kong, and the Australian Ambassador to the United States, Kevin Rudd, signed the U.S.-Australia Technology Safeguards Agreement in an afternoon ceremony. The agreement, endorsed by Australian Prime Minister Anthony Albanese and the Biden administration, provides the legal and technical framework for U.S. commercial space vehicles to launch from Australia. The White House said in a statement that the agreement protects sensitive U.S. technology and data in Australia, consistent with our shared non-proliferation goals. United States Secretary of State Antony Blinken delivered remarks at the signing, welcoming the new space-related opportunities and investments in bilateral commercial space launch activities. American companies will have access to more high-quality launch sites so that they can increase the frequency of their operations, he said. They'll be closer to the equator, where the Earth spins the fastest, so their rockets can get an extra boost and use less fuel. And of course, Americans will gain some brilliant Australian colleagues. Blinken emphasized that by creating fresh opportunities for the private sector, both nations will further their dedication to fostering well-compensated employment on a bilateral scale. Whether they're using satellites to make GPS navigation more accurate, or developing spacecraft to study the universe, these companies will help shape the future for our people and for our planet for decades to come, he said. The wide-ranging Biden administration discussions with Albanese included enhanced collaboration on clean energy. Australia and the U.S. Department of Energy intend to establish an Australia-U.S. Clean Energy Industry Council to advise the respective governments on clean energy industry development and cooperation, according to the White House. The Biden administration said the Australia-United States Climate, Critical Minerals, and Clean Energy Transformation Compact launched in May is an example of the commitment to enhance climate and clean energy cooperation. Also on the Albanese state visit agenda were defense and security concerns, particularly in the Pacific but also including Ukraine. The visit will also help enhance a trilateral defense cooperation with Japan and collaborative combat aircraft cooperation between the U.S. and Australia, according to the White House. Asteroid mining is one of those topics that sounds like it's straight out of science fiction. But, in recent years, with the growth of lower-cost launch options, mining space rocks could become downright economical. As an added plus, getting important resources from asteroids could help drive the switchover to clean environmental practices and technologies right here on Earth. In a recent exploratory paper, a group of academic researchers at Colorado School of Mines led by Dr. Maxwell Fleming joined an International Monetary Fund member Martin Sturmer to explore the topic. Their work looks at a variety of factors, including those lower launch costs, and asks the question, what if these costs continue to decline, making mining from asteroids or the moon feasible? For space-based mining, labor is an open question, since such activities probably would be mostly robotic. Investment capital probably isn't a problem, but the development of such technology has challenges. After examining the costs of mining here on Earth, both economic and environmental, the answer is fairly simple. They write, we find that a transition of mining from Earth to space could potentially allow for continued growth of metal use on Earth while limiting environmental and social costs. At the same time, such a transition could require an upper limit on the environmental and social costs on Earth to incentivize investment into R&D for space mining. These days, the cost of extracting minerals has increased 60 times over the past century. It's also incredibly environmentally damaging. Of course, there are challenges to getting space-based ores. First, miners have to get to the asteroids. Or, we need to build robotic mining operations that work on asteroids in the harsh environment of space. Then, all that ore has to be transported back to Earth for refining and eventual incorporation into our clean technologies. That could, in the long run, stimulate economic growth back here on the home planet.
Astronomy Daily, the podcast, with Steve Dunkley and Hallie.
Selling your car to Carvana is as easy as...
As easy as pie?
Sure. All you have to do is enter your license plate or VIN.
As easy as a stroll in the park.
Okay, then just answer a few questions and you'll get a real offer in seconds.
As easy as singing.
Why not? Schedule a pickup or drop off and Carvana will pay you that amount right on the spot.
As easy as playing guitar.
Actually, I find that kind of difficult. But selling your car to Carvana is as easy as...
Can be.
Visit Carvana.com or download the app to get an instant offer today.
Woodhouse Chrysler Dodge Jeep Ram is bringing you more power, capability, and savings with the full lineup of new Ram trucks during the Black Friday sales event going on all month long. Lease a 2024 Ram 1500 Crew Cab Bighorn for $429 per month. Visit our 2 convenient metro locations in Blair or Bellevue or online anytime. Lease for 42 months, 10,000 miles per year with approved credit. Tax, title, license extra. $2,500 down plus first payment and $299 doc fee to signing. Example stock number BC230242. Offer expires 11/30/2023. See dealer for details.
It will be great to see Australia more involved in the development of space.
Yes, that's good news, Hallie. It really is a perfect launching place with wide open spaces and so close to the equator. I can't help thinking, though, that the more traffic that goes up, the more debris that's going to be left up there. As we see more and more space rockets launched each week, and we have seen a lot of that, more technology is placed into orbit, the more problem of space junk grows and grows, not to mention the pollution from all the fuel burned en route. A review in the International Journal of Student Project Reporting has looked into the possible solutions to the problem of the abundance of space junk. Jennifer Stein, David Callisto, Elise Bedell, Ariana Thomas and Nicholas Valiente of the University of Florida in Gainesville, Florida, have looked at whether there are cost-effective, environmentally benign and efficient methods that might be used to minimise the harm from debris in space, which can damage other craft in orbit, potentially harm astronauts as well, and represent a risk, of course, when it falls back to Earth. In Australia here, we know that all too well when Skylab fell and distributed itself across parts of Western Australia. Space junk can be defined as non-functional man-made objects that remain in near-Earth orbit. There's a growing concern regarding such debris as there is no way to track it all, especially debris less than 10 millimetres or so in width, nor to allow for potential hazards to spacecraft and other satellites. Anything larger can be monitored and tracked with telescopes or radar. However, collisions between spacecraft can produce tens of thousands of tiny fragments that might pierce or otherwise damage another craft in the same orbit. A 25-year safety standard is in place that recommends that defunct objects are put into lower orbit so that they can fall into the Earth's atmosphere and burn up, or, if that's not possible, they can be moved up to a designated graveyard orbit. The team has reviewed 4 main approaches to dealing with space debris, and they considered pulsed laser ablation. This stands out as a time-efficient method for targeting numerous small and medium-sized pieces of debris pieces. However, it is a costly approach to a problem. A more cost-effective alternative might be the obviously named harpoon and net method. However, this is contingent on the absence of tumbling debris. Another also obviously named approach that might be used is the claw capture mechanism. A magnetic capture method was also considered, which could be adept at assimilating debris even under tumbling conditions. All of these approaches, with the exception of laser ablations, would take months to capture and drag an object such as a defunct satellite into a lower orbit that can fall into the Earth's atmosphere. Fundamentally, none of the approaches reviewed would work perfectly, nor are any of them likely to be cost-effective or time-efficient with current technology. However, it might be that the combination of technologies and techniques could work synergistically to overcome the drawbacks of each and build on their strengths. Given how much debris is already in orbit around our planet, and the continued additions to this debris belt, now is the time to launch research programs to develop the cleanup technology sooner rather than later. It may seem extreme, but wouldn't it be sad to look up through our telescopes and see clouds of debris floating by? Whoops, and there it goes, another episode of Astronomy Daily for the 30th of the 10th, 2023. And our regular reminder that you can find all the back editions of this podcast and our parent podcast, Space Nuts, with Andrew Dunkley and Professor Fred Watson, as well as current and back episodes of our podcast, Astronomy Daily with Tim Gibbs from the studio in Bath, England, and yours truly, Steve Dunkley from the Australian studio at this address, spacenuts.io or bitesz.com, that's BITESZ or Z.com. So head over there and click the links and enjoy your fill of space, science and stuff. But that's not all. While you're there, sign up and receive the Astronomy Daily newsletter. It's an all-you-can-eat buffet of all the news that's orbital, astronomical and wow. So closer to home, you can also drop into the Space Nuts Facebook group page and say hi. We'd love to hear from you. I know I would. Thanks again for joining us on Astronomy Daily.
Thanks for joining us, everyone.
See you later.
Astronomy Daily, the podcast, with your host, Steve Dunkley.